Dr. Andrea Pilotto is from Pavia, from Simone Porcelli lab. And today we'll present something about cardiovascular and peripheral limitation to oxygen cascade in middle age and elderly. Have fun.
Thank you, Gaspare, and we have a last-minute modification. We will speak also about the impact of physical activity in elderly. And we know that there is a progressive decline of VO2 max during aging. This is mainly due to a reduction in the central component, the reduction in cardiac function, and also at peripheral level, reduction, for example, in muscle oxidative capacity. But we know that physical exercise can mitigate this effect. In this graph we can see elite master athletes VO2 max compared to age-matched specific at the same specific age individuals. And for example, at 80s, elite master athletes can have a VO2 max that will be higher than 50% of the population in their 20s. So from this context, our goal was to quantify and compare the role of central and peripheral limitation to the oxygen cascade between comparing untrained and trained individuals at different ages. So these data are cross-sectional data coming from a bigger project that is trajectory that is aiming to look at longitudinal effect of aging. But for this data we analyzed males and females participants at different ages, young subject around 30s, untrained middle-aged subject around 60s, and untrained or sedentary old subject around 80s. And then we have the possibility to also test trained elderly subject with a higher VO2 max that is included in this subject. There are master athletes competing at national and international level competition. We tested with a cardiopulmonary incremental exercise test of the circular ergometer at sea level. We measure oxygen consumption and cardiac output using transthoracic bioimpedance. And the results from this data were a progressive decline of maximal oxygen consumption coming from in healthy untrained subjects from young to mid and to elderly subjects, whereas in all trained these data are pretty similar to the values of young subjects. And the cardiac output follow the same trend. Then we also took blood sample from this subject. Unfortunately, these data are still ongoing in analysis, so we assumed the same. We know that it's a strong limitation. We assume the same concentration of hemoglobin for all the participants, and then we also assume the arterial oxygen saturation and arterial oxygen pressure. And it was useful to calculate the arterial oxygen concentration and to calculate the oxygen delivery. And the trend is pretty the same. We have an untrained subject that presents a decline in oxygen delivery, while all the trained subjects preserve the oxygen delivery. From this data, we use the Pramper model that is describe the oxygen cascade as a sequence of resistances and pressure gradients during the oxygen pathway. Anyway, long story short, this is very useful to calculate what is the cardiovascular fraction of the oxygen flow limitation. And what we found is that from young subjects to elderly, we are moving from 70% of the cardiovascular fraction around 50%, when this value is maintained very high in all trained subjects, around 70%. And the remaining part is the peripheral fraction, that is exactly the opposite trend. And what is interesting is that at 80 years, we have a double, like a 50% of the fraction from cardiovascular to peripheral component. So we decided to look better at the last step of the oxygen cascade, where the peripheral fraction is composed by two other components. One is the diffusive component, so the movement of the oxygen from the red blood cells to the myocyte, and then the utilization of oxygen from mitochondria that is giving us information about the capacity of mitochondria to utilize oxygen. And to analyze better this aspect, we use near-infrared spectroscopy on the vastus lateralis on a subset of population, and we perform this protocol that we published a few years ago, using the calculation of the recovery rate constant during the intermittent arterial occlusion after a brief exercise, and in two different conditions of oxygen availability. In high oxygen or not limiting oxygen condition, we have the Ki, so the recovery rate constant in high condition, that is directly related to the mitochondrial function. And then we have the same protocol, but in a condition of limiting oxygen availability, and we can measure the K load. This parameter is not related to the mitochondrial function, but can give us some important information about the diffusing, the muscle oxygen diffusion. And the difference between Ki and K low give us the parameter so-called delta K. And to briefly, we have two extreme scenarios where delta K close to zero represents an oxidative limitation to the intramuscular oxygen flow, whereas a delta K that is higher, where the dots are lying on the same theoretical diffusion line, this represents a diffusion limitation to the intramuscular oxygen flow. And the results from this protocol show us that from young to middle age and also elderly that is maintained, there is a reduction in mitochondrial function, whereas all trained subjects present a very high mitochondrial function compared to other groups. And also delta K present the same trend. This means that in young subject, the limitation to the intramuscular flow is mainly related to a diffusive limitation, whereas in middle-aged and elderly untrained subject, this limitation is mainly related to, is moving towards an oxidative limitation. And in all trained subjects, the profile is very similar to the young one. So, wrapping together everything, with this data we confirm exactly what Professor Capelli and colleagues published very recently, and we found that the oxygen in untrained subject is the decline in maximal oxygen consumption is characterized by a not uniform increment in cardiovascular and peripheral resistances, where the peripheral resistances is incremented during aging at an higher rate than the cardiovascular component, leading to a 50% contribution of both components around the 80s. And this increment in the peripheral resistances is primarily driven by a reduction in mitochondrial function. Anyway, the muscle diffusion may play an important role, as can we see from these electron microscopy images, where in an old subject we have a very long distance between capillary to the mitochondria compared to the young subject. However, the good news is that an active lifestyle can mitigate this decline at both cardiovascular in the cardiovascular factors and also peripheral factors in both muscle oxidative and diffusing capacity, and this helps to maintain a fractional limitation profile that is very similar to the young participants. I want to thank all the people involved in the project, and I want to thank also Professor Di Tampero, Professor Capelli, Tam, and Professor Ferretti for inspiring me in using this model, and I want to thank you, all of you, for your attention.
Thank you, Andrea. Questions?
Hi, this is Fabio Esposito from the University of Milan. Thank you very much for your very challenging presentation. I wonder what happens when you use an exercise modality that frees the muscle from the central limitations, such as the small muscle mass exercise, because that's the real scenario where you can see the diffusing or mitochondrial limitation to oxygen delivery to the mitochondria. Thank you.
Thank you for the question. This is absolutely an interesting point. Using probably a small muscle mass exercise is better. We can change completely the fractional limitation between cardiovascular and peripheral, moving probably more close to 50-50 also in young subjects. And I don't know, this is interesting. Probably we will see that in aging, in untrained subject, the peripheral component will be higher than 50%. This is my guess, but I would like to answer with real data. Thank you.
Hi, my name is Emanuele. I'm a research associate at the University of Bristol. I preface this by saying that I'm an engineer, I'm not a physiologist, so this might be a very basic question. But what I wanted to ask is the sensor that you use for the oxygen uptake, if that's what it is for. What kind of sensor it is and how does it work?
The sensor for the muscle?
Yeah.
Oh, okay, yeah. It's the near-infrared spectroscopy. It's a sensor that is able to detect there are different technologies, but it is able to detect the hemodynamic changes inside the muscle capillaries. And then with different technology, there is some quantitative, this was qualitative, so measuring the changes, you can understand from the baseline what is happening in the muscle and understand if there is an extraction of oxygen or not, so you can estimate the auxiliary capacity or the function of muscle in utilizing oxygen.
Last quick question.
Daria Badas from the Physiological Society. Thank you so much for such a clear and elegant presentation. I obviously have skin in the game, so I just wanted to ask, and again this may be very basic, the cohort that you used were elderly elite athletes who I would imagine have trained consistently through their lives. Do you think from this research, because you referred to it, the performance of the mitochondria, do you think if you take people then in middle age that you can see a reverse in those untrained middle-aged physiologists to align to a more elite, how the elites were doing? So is it because the elite athletes have been doing it all the way through their lives, and what impact does it make coming to exercise later in life?
Actually, this subject that we analyzed were master athletes, but most of them you start training properly, in structured training from 50 or 60 years old. So they were not all the lifespan. But what I'm suggesting is probably also if someone is starting at 30 years old, probably some good evidence of this effect is also visible, evident at middle age.
Thank you very much. Much more question, I think, during lunch, coffee break, all that stuff. So, thank you and clap there.